Thank you all for joining us today for a Carbon Mapper Waste webinar on landfill emissions in our data portal. Good morning, good afternoon, good evening from wherever you're joining in the world. We're so excited to have you here. I'm Annabelle Blair, Communications Manager at Carbon Mapper. Some of you might be familiar with Carbon Mapper, but for those who aren't, we are a nonprofit organization focused on helping to drive emissions reductions by making methane and carbon dioxide data actionable and accessible. We use remote sensing technology to detect, pinpoint, and quantify methane and CO2 point source emissions at the scale of individual facilities, and we make that data accessible and available via our public data portal. And to deliver on this mission, we also lead the Carbon Mapper Coalition. It's a unique public-private partnership powered by philanthropy to develop and deploy satellites that will help routinely detect, monitor, and quantify major emitting sources. The coalition's first satellite, Tanager 1, was launched this summer. It was developed by Planet Labs with technology from NASA's Jet Propulsion Laboratory. And ultimately, our goal is to scale to provide sustained monitoring of up to 90% of CO2 and methane super emitters globally. But we also know that data alone isn't enough to drive reductions, and we need more tools and capacity to turn this data into action. So our goal today is to give an introduction on the types of waste emissions data that we provide, and also an overview of a little bit of how to kind of access and see that data on our portal. So during today's webinar, Dr. Tia Scarpelli, Carbon Mapper's Waste Lead, will provide an overview of why we're focused on point sources in the waste sector, also known as super emitters, and how our methane data can be applied to reduce waste from landfills. At the end, we'll have time for questions, about 15 minutes. We'll be using the Q&A feature in the Zoom webinar. It's at the bottom of your screens. There should be an icon that you can go ahead and submit questions when we begin the Q&A session. And we'll also have the opportunity for folks to raise hands and ask questions live. We do want this to be an engaging time and an area where people can really ask questions. Tia is very excited to speak with you all. So when we open that up, we'll feel free to raise hands and have those as well. This is the second webinar of a series that we are planning to provide a little bit more sector and user-specific guidance on our methane and CO2 data. The first one was a detailed webinar that was really focused on the data portal's functionality and how to use it, and we'll share that link in the chat and also as a resource after the webinar. This webinar is being recorded and it will be shared out with all of you and anyone who registered afterward, but please stay tuned for more information on future webinars and other things that we're up to. So with that, I'll go ahead and hand it over to Tia.
Thanks so much, Annabelle. As was said, I'm Tia Scarpelli. I'm the waste lead at Carbon Mapper. So if you ever have questions about waste, I'd be the person that you'd be directed to. I'm going to go through a few slides, and then as Annabelle said, I'm going to go and do a couple different things in the data portal, though this is going to be pretty brief. And so if you have kind of further questions afterward, feel free to reach out. So just want to start off by doing a little bit of definitions. As Annabelle pointed out, we kind of as an organization really focus on what we call point sources, or these can also be referred to as super emitters. The way that we define what a point source or emitter is it's a large emission source. This can be for methane or for CO2, though I'm going to really focus on methane today. It's a large source coming from a concentrated area on the ground, like a localized area. This is typically, a specific piece of infrastructure or equipment. It can also be, a localized region on like a landfill, for example. And so this diagram on the right here is just meant to show these are different kind of types of equipment and activities where we've seen these point sources of methane originating from on US landfills. So it's kind of ranges from, fugitive leaks from a collection system or cover issues to the landfill working area where kind of active waste is being added to the landfill. Just want to note as well that, so there's these other types of emission sources called what we call area sources, which are more spread out and diffuse, and they usually come from kind of a broad area. These also occur at landfills. If you think through like diffuse spread of methane through cover. This is not the type of emission source we're going to focus on here today, and it's not really something our organization focuses on, but just recognizing that this is another source of methane at the landfill. So I want to just briefly cover, why do we focus on these point source methane emitters and kind of how we think of observing in that context. So, these large methane sources are really important for if we want to combat short-term climate change. Methane is a very potent greenhouse gas, especially on shorter time scales. And these point source methane emissions can be, we see them across different economic sectors, ranging from oil and gas to the waste sector. And that's just to show this kind of how we see this globally. This map here is just a screenshot from our data portal, so you can go and kind of access all this data there. But just showing these purple dots are showing where around the world we've detected these large methane point sources in the waste sector. So you can really see that it's not just one region of the world that they're found in, but really across the globe. And these can contribute a large fraction of regional emissions. And so if you really want to combat short-term climate change and have an impact on methane emission reductions, these can be a real tool for mitigation and targeting these sources. So we see methane monitoring as one of those key tools to help us kind of inform mitigation and make informed decisions regarding what we want to prioritize for methane mitigation. There's a couple key factors when we think of how to do this monitoring successfully. One of them is thinking about having kind of global coverage of your monitoring system. And this is especially true when we think about satellites, because they provide this kind of global coverage of the world, especially in regions where we don't necessarily have on the ground monitoring, and we might not have any other types of observational data of true methane emissions. Another factor is having regular monitoring. This is really, important when we think of the waste sector, especially because these sources can be highly variable. And so having kind of not just a one-off observation, but having repeat monitoring over time, so we can get a feel for, is there seasonality in the emissions that we're seeing, for example. And then the third one is having high sensitivity instruments. And this is really the idea of, we focus on these methane point sources, but we don't just want to see, only the biggest, but we want to see kind of a good sample of the population, so we can really have a high impact on mitigation. And so here is making sure that the kind of instrument that you're doing your observation with is able to kind of see a large fraction of that total population of emitters. And on the bottom here, on the bottom right, is just some example images of what some of these methane point sources we've seen in kind of the waste sector. This ranges from, gas to energy facilities at landfills where they're kind of using it for beneficial use, to kind of the landfill itself and even dump sites. So that's more so outside the US. So I just want to now give a little bit of background on kind of the technology. So we use both satellite and aircraft, and we can deploy the sensor on either one of these. The sensors that we use are a type of passive remote sensing. So this means that they rely on solar radiation. So this is radiation coming in from the sun. It's going to bounce off the Earth's surface, and then back to our sensor. And so our sensor is going to, be sensitive to that radiation. This is, we do this in the part of the radiation spectrum where methane and CO2 absorb, and so we can see any signal from the presence of those gases. One important thing to note here when you do passive remote sensing is that we really need the sun to be present. And so if, for example, there are clouds present, that's going to hinder our ability to kind of do the monitoring with this technology. Though, there can be, it doesn't necessarily mean that you need a complete cloud-free sky, but at least over the source that you want to observe, you can't have dense clouds present. On the right here, I'm just showing an example of kind of when we go and deploy this technology, what it is that we're kind of seeing and how we're observing. And so the specific instrument that we use is called an imaging spectrometer. And again, we can deploy this on aircraft or satellite. And what it's doing is it's kind of providing a bird's eye view of that methane as it's being emitted from the source. So here I'm just showing kind of a little animation of how, as the methane from these point sources is kind of being emitted and leaving the source, it's creating this three-dimensional methane plume. And then our instrument is observing from a bird's eye view, kind of a snapshot in time of that methane plume. And so it's seeing, and so we're creating this kind of, you see it as like a rainbow blob. That's the methane concentration. And it's really the kind of in the column between the instrument and the source, how much methane is present. So just important to note when you're trying to translate this to something like you might be familiar with in the waste sector, that it's actually kind of where the start of the plume is, where we're marking where the origin of the plume is where kind of we expect the highest concentration at the surface of the landfill. Just going to briefly kind of go into our different instruments. I highly recommend, checking out that other webinar that Annabelle mentioned if you want more info. But, we do process data from different instruments, and you'll find this data all on our public data portal. These can broadly be in two categories. One is when we deploy on aircraft, on an airplane, that's on the left here, or on satellites, which are on the right. And there's kind of a range of satellites as well. The satellite that's in the middle, the Tanager satellite, is the Carbon Mapper Coalition satellite. This one's the one we just recently launched and are really looking forward to, starting to get data in from. The important thing to note here is that depending on kind of the type of sensor you have in these different, aircraft versus satellite, they have different capabilities. And so just recognizing that when you're going in and you're trying to interpret the data, that, these different instruments have different capabilities. So for the aircraft, generally speaking, these are going to have finer spatial resolution. So this is like the pixel size in your image. And you're also going to be able to detect smaller sources, though still staying in this idea of point sources. And but these aircraft are going to have lower spatial coverage. So we're typically deploying out for a campaign for a couple of weeks in a given region, and then we're stopping. Versus the satellites, these are going to have slightly coarser spatial resolution, and they're going to be able to see the larger sources, not quite as small as the aircraft can see, but they're going to have this broader spatial coverage in regions where we're not able to get to with the aircraft, for example. So just recognizing that there's kind of a range of capabilities depending on the instrument. And these are just some example plume images of kind of methane as it's being emitted from the site, and remembering that this is a kind of bird's eye view of the methane plume as it's being kind of blown away from the landfill or dump site, and just showing you kind of how these different instruments observe. So I'm not going to go into detail on how we kind of create our data. That was really covered in our other webinar. So, again, recommend checking that out if that's of interest to you. But really want to get into kind of how we work with stakeholders and how we really bridge that gap between just collecting the data and actually doing the mitigation action on the site. And so to do this, we work with a lot of varied stakeholders. This can range from regulators to industry to other NGOs. And really here, the key is, having partners that can help us, translate our data to mitigation action. But recognizing that there is kind of different ways that can be done. It's not always, and this might depend on the type of source that you're observing at the landfill. So here I've grouped these into three broad categories. On the top, you see this direct mitigation. So this is the idea when, we have this leak that we're observing. It might be from, a fugitive equipment leak, like maybe there's a downed well, or there's a kind of crack in the cover. And so this is, an unknown leak to the operator where we've identified it as a methane source with our technology. We can feed that information to the operator. They can go and do follow-up on site and, do the mitigation action and then report this back to us. And ideally, we'd also be able to go in then and verify with our observations that this was successful. But recognizing that this is not always, the mitigation on site is not always this simple and not always this easy. These are complex engineered systems. And so on the bottom, I just have this different example of kind of doing more indirect mitigation where you're having this data exchange with the operator. We're notifying the operator like, hey, we're seeing this large emission source, and they're able to verify that that area is a part of the landfill where, for example, we're actively filling or there's a construction event occurring. And these are just intrinsic emissions for a landfill that are very, can be difficult to mitigate. And so it's not just as simple as, making a simple fix on the site. And so here the idea is, can we then use this data collection, both the data on the facility, but also the data on the methane emissions to, long-term track what best practices at these kind of more difficult to mitigate sources are best able to kind of reduce emissions over time. And so this is really thinking about, looking at what ways can we use the data to inform best practices. And then on the far right, I have an example of, zooming out even more and thinking about, how do we do traditional emissions accounting at these types of methane sources? And so thinking about integrating the methane observation data with site facility data to put that into improved models to better track emissions. And this can, hopefully eventually feed more informed mitigation strategies in the end. And so I just want to kind of go through a couple little examples or use cases of where, these different strategies were undertaken. First, thinking about that kind of direct mitigation strategy. So here, was an example landfill in California where, we were able to observe these large emission sources with, this was an airborne campaign. So we used the airplane with the instrument on board. And we saw these large emission sources and were able to feed that information to the operator in collaboration with local regulatory agencies. And they were actually able to go and take action on site and make changes to the, the cover and other parts of the landfill. And through these changes, they were able to mitigate that source. And we were able to re-observe the site after these changes were made and confirm that, yes, those changes at that part of the landfill were successful. And we do see, the intended reduction in emissions. Some key factors here to think about for kind of doing this type of mitigation are that, we had this important data sharing process with the operator. And we were working with a stakeholder who was willing and able to make changes on the site. Because, we as a carbon mapper aren't able to actually go and do the mitigation. We really rely on stakeholders and partners to do that. And so helping, them understand what the data can tell them and help them use it as a tool to do that mitigation. I think here too, another key to point out is that, using the data to verify success. And so here we were able to do follow-up observations because the operator was able to provide us information that those changes were made on the site. And so really having that back and forth communication. So this is a slightly more zoomed out example of where we were both doing the direct and indirect mitigation. So this was working in collaboration with California Air Resources Board, where they were really, we were observing multiple landfills across the state of California over a 3-year time period. And, through this process, there was notifications sent to operators about different kind of plume detections that were made. So again, really relying on that data sharing process. And so for a handful of these cases, there was direct mitigation that was able to be done. And so if you look on the bottom left here, I just have a kind of breakdown of, on the top, it's showing, mitigatable sources where the operator did not know about this leak and they were able to go out and make changes in response to the data. Whereas this, on the bottom of that table, it's showing this type C. This is with types where, these were allowable emissions, and so there wasn't an easy mitigatable solution right at the time that the emissions were observed. But we're having this data collection across many methane emitting landfills to try to understand, okay, what are the major sources at landfills that we might want to think about best practices moving forward into the future. And so this is really a kind of an indirect leading to future mitigation. And so key factors here, we're having that data sharing and also having operators being willing to do voluntary follow-up on the site. And so really having that collaboration. And then also kind of doing this data collection across a broad range of facilities. So really, for example, able to identify that, the working area across many facilities was leading to these large point source emissions. And so thinking about how that can inform best practices moving forward. And then also doing this integration of the site data that the operator, has this knowledge on site of what's going on that day with the observational data. So we can align, what's going on at the site that may be causing these emissions. And then lastly, zooming out even further, thinking more on a regional jurisdictional scale, this data can be used to inform how we account for emissions and how we strategize mitigation at the city scale or at the state scale, for example. And so understanding how do we bring together these different tools that cities already use to improve their mitigation planning. And so this ranges from the methane monitoring data to the waste data on waste flows and waste characterization, and incorporating this into models. So trying to use these kind of improved data sources to have more accurate modeling of what the best mitigation pathways are for a jurisdiction. Some key factors here are, having the stakeholder engagement early on to understand, what is it that the stakeholders are interested in, and helping each other understand, where we're coming from. Also having, the data collection that's happening, not just the methane monitoring data, but also having accurate information on waste flows. And then also kind of integrating these different tools together, and so that the city can make informed decisions. So I'm going to go on to kind of give you a little walkthrough of the data portal in a second. But before I do that, I just want to go through a couple quick definitions. We'll do the data portal walkthrough, and then we'll come back for Q&A. So the first definition is just this concept of what we Carbon Mapper in our data portal consider a source. And so this is a geographic region from which emissions originate. And so for the purpose of our data portal, we consider a landfill as a source. So when you go to our data portal, you're going to see these sources marked in purple dots. And so the idea here is to consolidate the observations made at one landfill into a single kind of information on that source. And you'll see kind of average emission rates or source emission rates for the site. And if you can click on it, you can get more information. And so when you then click on one of these sources, you're going to then be taken into kind of a list of different observations. And this is kind of methane plume information. So this is a one snapshot in time observation of the methane as it's leaving the site. And so what happens is, you have this landfill that has an emission occurring, and that methane is moving up into the atmosphere, and we're kind of taking that bird's eye view again of that kind of excess mass of methane in the atmosphere. And so that's where you get this kind of rainbow image of methane. And so remembering that this is a kind of two-dimensional image of a 3D methane plume. And so the part that's going to most closely translate to where the emission is kind of leaving the surface of your site is the plume origin. So this is the latitude, longitude, location of kind of where we're estimating the source, or the kind of location of where this emission is occurring on the site. Okay, so before we kind of get into the Q&A, I'm just going to go into the data portal for a second and give a little walkthrough of what it is that you can see. If you want more information on the data portal, I highly recommend watching the other webinar. This is what you would see if you come into our data portal here. What you're seeing is these are different kind of methane sources that we've observed, remembering that our technology is really focused on these methane point sources. We also have some CO2 sources in here as well, but noting that I'm primarily focused on methane today. And so on the left, what you'll see is there's a search bar. You can search by location, or if you know the actual kind of coordinates of where you want to look at methane and where you want to look at our sources. You can also then kind of filter using different filters. This includes kind of by date, sector, and instrument. Noting that for instrument, you can also differentiate. So this includes both satellite and aircraft mounted instruments. And these are kind of different filters you can apply for the sources. Like, let's say you only want to look at sources that are really the largest emitters. So you can filter to just those kind of by the emission rate. There's this other feature called plume cluster distance, which I'm going to go to in a second. But the idea here is, as I said, we kind of clump together all the methane observations that are made what we kind of estimate to be the landfill. And so we use a kind of 500-meter distance around the site to kind of cluster those sources or those plumes together. But you can kind of adjust this for different purposes. Noting as well that on the kind of right side here, you can kind of do this drop down and look at, some information on the individual sources. So if you can click on these and zoom into a particular source, and it'll show you kind of all the information on that source and the observations that we've made. And when you're in there as well, you can also change to different base maps if you want to see kind of the visual imagery on that as well. I'm going to zoom back out here though, and then also show some features that we have in the layers tab. So I'm going to go back to the gray tab. So one of the other features here is you can turn off. Right now I have it clustering by how many sources are in a given region, but you can turn that off if you want to see them not clustered. And then you can also look at this concept called coverage. This is showing where have we observed with our instruments. You'll notice that in some regions we've made observations, but we haven't actually detected any plumes. And so this is just something important to note of if you want to see like, have they observed in a given region? You can turn on this coverage visibility. Okay. So now I'm going to show you just a couple specific things that I do in a data portal to help me understand waste emissions. One of them is using this search bar, and we can type in a given area. Let's say that I want to look at, a state. So here, if I type in a location, you can zoom to that location, or you can use what we call this administrative area geometries. So I'm going to use this one for Texas. And what it's going to do is it's going to kind of create what we call an area of interest and filter out only the emission sources that we've detected within the given region that I gave it. One of the cool features here is that you can then look at what we have the summary statistics, and it's basically consolidating together all of the sources that we have within this area of interest and totaling up the emissions by sector. And so here we can see that when it does that, it's showing that within the state of Texas, for the point sources that we've detected, oil and gas is really the dominant sector. And so most of these sources are associated with oil and gas activities. But then if I instead remove that, and I want to zoom into a particular place, let's say I want to zoom into a specific city in Texas. So now I'm going to zoom into the Houston area. What I can do is draw my own area of interest. And so here I'm going to draw a rectangle just around the greater Houston area. And I'm going to look at summary statistics again. And what I see is for the greater Houston area, it's actually the waste sector that is dominating emissions for these point source methane sources. And so if you're kind of a stakeholder who cares about these kind of city scale regional budgets, you can use this tool to kind of say, where should I target my interest and my effort in terms of the mitigation potential for these different sectors? So now I'm going to remove this, and I'm going to filter and just zoom in on a particular landfill. So here, if you only care about waste sources, you can put on this filter by sector. And so now I just want to see my solid waste sources. And let's say I want to zoom in on a particular site. So you can get, as I said, more information on these are all the individual observations that we've made. You can also see if you click on this null detects, it allows you to see both times where we've kind of observed but not seen any emissions, in addition to the times where we've seen plumes. And then I also just want to kind of show you this feature of the plume cluster distance. So sometimes as an operator, you might want to know, okay, where are kind of the sources, where on the site have we been detecting these kind of emission sources, where are the plumes originating from? And so what you can do is instead of having us clump together all of the observations into one purple point here, we can turn this down to just 1 meter cluster distance. And it's essentially going to show you the plume origins for all of the different observations that we've made. And we can turn on the other base map here. And so it really allows you to see, at the site, what region of the landfill are my emissions mostly coming from? and remembering that these are the point source emissions. And what you can do as well is if you have access to high resolution imagery at your site, especially when, a given period of time throughout the year, you can go in and download this data yourself and go into a platform like Google Earth and kind of overlay these locations of the plume origins with your own visual imagery of the site, to try to assess, what's going on at the site at the location where we've detected these emission sources. So that's all I have to show today on the data portal. Again, though, if you have additional questions, please reach out. And now we're gonna, I think, open it up to the Q&A section. But just noting, I'll leave this up here as well. This is some resources that are available if you have more questions. There's an info@carbonmapper.org email here as well that you can email us questions on. And just noting as well that if you want to stay up to date, I highly recommend signing up for our newsletter. This is kind of where you can get the most up-to-date information. And always looking to work with people as well. So please, if you're a stakeholder who's interested in learning more or working with us in some way, please reach out. And I think, Annabelle, we're going to move to the Q&A now.
Yeah, thanks so much, Tia. We have had a ton of great questions coming in the Q&A chat form. We probably won't be able to get to all of your questions with today's time, and we'd really like this to be an interactive space. So I'd now like to just open up the floor for people who want to raise their hand and ask your question live. We'll try to get to as many as we can. Tia, that'll also give you a second to take a peek at the Q&A box in the meantime. I know you've been busy focused on the presentation, but yeah, please feel free to raise your hand and we'll try to get to as many people as possible. Give a couple seconds for people to formulate their question, and yeah, Tia, feel free to take a look at some of those in the Q&A in the meantime, and if there's one that really stands out you'd like to address, we can start there while we're waiting for folks to raise hands.
I do see some asking about kind of, and I think we broadly recognize that there are, other satellites that exist out there, and there's other data sources, and so it can be slightly overwhelming sometimes to understand, what the capabilities of these different satellites are, and kind of how those intercomparisons might work. And we'll say that our science team does, collaborate with a lot of other agencies that have satellite observations. And you can learn more about this. We have kind of a lot of our science and news findings on our website. If you have specific questions, I recommend reaching out regarding kind of how we do that intercomparison. As I said, we process data from satellites that have kind of the raw radiance data available. And then, so that's kind of how we decide of where we pull data from, but really focusing on these satellites that do those kind of point source imaging, as opposed to some satellites that focus more on kind of those broader regional fluxes. So that's something just too that, different methane observing satellites do different things, and so they're not all the same. So we're really focused on what we call these kind of point source imaging satellites.
Awesome. And Tia, it looks like we have a hand raised. So once we go ahead, it looks like Mohammed is first, and there should be a queue which will allow your mic to be unmuted. So hopefully you can see that and respond, Mohammed.
Hello, you are listening?
Yep.
Yeah, we can hear you.
Oh, thank you so much for your this session. So it is very important. My question is, what type of satellite is good for the monitoring methane emissions, like the Sentinel, Landsat, MODES, and what type of satellite data is good for monitoring? And what type of sensors it is good, and how we can monitor the NC2 or the ground data emissions of the methanes, which type of detectors is good, and how we can measure and correlate these two type of data.
Yeah, thank you for that question. I think it's a big question. I think kind of thinking broadly, depending on your use case of what you want to do with it, remembering that these satellites are mostly observing, so you want to first pick a satellite that actually observes methane. If you're interested in methane emissions, you want to pick one that's going to actually kind of observe methane. There are ones so the type of technology we use is really designed to look at these point sources. And there's kind of a certain methodology that you do to get to methane emissions related to those point sources at landfills. There are other types of satellites like the Tropomi instrument that are more designed to get total methane in the atmosphere. And so, they are more going to get you an emission that's averaged over time. And it's going to be, it will include both the diffuse and the point source. So it's going to include kind of both that area and the point source that I mentioned at the beginning of the presentation. But the difficulty there is that, they're not as high spatial resolution. And so kind of the ability to say that a certain amount of methane is coming from a specific facility is more difficult for that type of satellite. So there's a trade-off between, our technology is really providing a snapshot in time. Though the more observations we can do over, a year, for example, the more kind of confident we are in saying that that's kind of representative of kind of annual emissions. But we are able to very, closely and accurately geolocate our kind of observations that we have. And so we're confident that it's coming from the landfill, and we can kind of say specifically. So to me, that's, it is really useful for understanding a single facility's emissions. Whereas those other instruments are maybe better designed for looking at regional methane, not a specific facility's methane. So I think but there is a trade-off, and it is kind of a sliding scale. And ideally you'd have a tiered system where you can combine information from the different satellites to kind of understand your emissions.
Thanks, Tia. Looks like next we have a question from Stephen. So same process, we'll go ahead and unmute.
Can you hear me?
Yep.
Thank you. So, first off, thank you again so much for this talk today. I guess my question kind of piggybacks off of Mohammed's question a little bit. With regards to satellites like Tropomi and the new methane sat that is now in the air and will hopefully have data somewhat soon. They have more of a periodic orbit, which can give full global domain. I'm just wondering with the Tanager satellite or instrument, if we'd be looking at some sort of similar type domaining, like say when you showed the slide that had the observations from well, actually, no, you weren't showing the slide. It was the demonstration. I noticed that most of the observations are constrained to outside of the poles. So I was wondering if Tanager would have more spatial coverage than that, or if it would just be constrained within certain areas.
Yeah. So first, when I showed the coverage on the data portal, right now we don't have any Tanager data in the data portal. So that's really most of the global stuff outside of the US is from us processing data from the NASA EMIT satellite. This is on board the International Space Station. So the cutoffs you see at the poles are because that's the orbit of the International Space Station. Whereas with Tanager, we aren't limited to just kind of below and above 60 degrees. And so we're below 60 degrees north, above 60 degrees south. So we actually can get we have a polar Earth orbit, so we can see above or there. I think it is important to note that, and this is true with all passive remote sensing satellites, not just ours, that you need sunlight. And so in kind of times of the year when there's less sunlight available at the, near the poles, this is going to make it difficult to observe there, both for us and for, Tripomia is also a passive remote sensing. So they're also going to have that difficulty. So I think, yeah, in terms of coverage, like we will have global coverage with Tanager satellite. There will be, it is a tasked instrument though, so we do have some capabilities to look at particular locations as well. And then in terms of kind of broadly coverage, over time, the Tripomia is generally going to have more kind of spatial coverage, just because it's kind of its swath that it's looking at is larger. But it's not going to give you that facility scale information on emission sources. So there's a trade-off between whether or not you want, broader spatial coverage versus kind of having that unique facility or that individual facility information. So kind of depending on your use case, if your interest is really at the facility scale, it's really these point source imaging satellites that are, a great tool to use for that. Whereas if you're more interested in kind of regional emissions over, let's say, kind of like the European continent or the kind of different multiple countries, Tripomia instrument might make more sense. So there's kind of that trade-off.
That makes sense. Thank you so much.
Thanks, Tia. Next, we have a question from Brian Loma.
Hi, thank you so much. This has been a great presentation. I'm wondering a couple of things. First, you guys working with state organizations here in Colorado. Our Department of Public Health is trying to do more mapping, and there's a lot of methodologies being implemented between revisions in methane rules for landfill emissions, implementation of organic and construction materials and diversion. And we have our state EPR all coming into play pretty much just at one time. So I'm wondering about how this mapping is being utilized as far as like helping local states, and whether the blending of like fixed sensors or drone sensors to really help get that deeper footprint.
Yeah, thanks so much, Brian. So we are, we do work with states, like the example I showed with California. We have, we have talked and worked with in the past, the Colorado state government, the Department of Public Health, and we are aware of kind of the things going on with landfills in Colorado right now. And we are kind of trying to help make sure they're aware of what we do and how we can kind of coordinate together. I would say, like, in kind of thinking about these different, you mentioned different types of observing kind of methodologies and different types of instruments. And I think, we are very aware as an organization that, ideally you'd really want a tiered system of monitoring that can bring together kind of the different advantages of each of these different technologies, especially somewhere like a landfill where you have complex emissions. You have multiple sources kind of emitting at the same time, and you have, the site might change day to day as well. And so I think kind of bringing together how can these tools complement each other really well. Our tool has the benefit that, we can kind of get a full coverage of the site, and we can see any like large emission sources. So it's really helping prioritize those large sources. Whereas, you might be using, typical when you're doing a walking survey with a handheld sensor, or if you're doing deploying drones, that's going to help you find those really small leaks. And so there's kind of a trade-off between, seeing the big stuff and really getting that, understanding what the emission contribution of the big stuff is, and then also kind of deploying these other technologies to find those small leaks that, might have, for example, fugitive leaks from kind of around your wells, for example. And so the different technologies kind of fit different purposes and can really complement each other really well.
Thanks, Tia, and thanks, Brian, for the question. We're almost at time, so I think we can take one more from Michael.
Yeah, it's a comment and a question in a way. You kind of like skirted around on the conversation around the lower sensitivity level. The problem with the lower sensitivity level, and you pointed to the 100 kilograms per hour, I think satellites based upon the METEC studies go down to about 20 to 30 kilograms per hour. But the bigger issue with that one is that that is really only pinpointing the large sources, and the vast majority of emissions are coming from aerial sources, where satellites technically would be better to use if they would have the sensitivity to that. So my question to you is, how are you going to capture the real large sources, which are the wetlands, the aerial landfills, the rice fields, and the feedlots? Because if we're just going after waste facilities and oil and gas, that is maybe convenient from a fundraising perspective for an NGO, but it doesn't really address the real large emissions, which are in the agricultural and large area landfill side.
Yeah, thanks so much, Michael. And yeah, there are a lot of methane sources, and there are, many, I think a lot of area of research on the wetland sources in the peatlands. Our focus as an organization is really on these point sources. That's the technology that we use. And I think really where we, part of the focus for this is because that's where a lot of there is this high mitigation potential that we can use known technologies, and in some cases even have, economic incentives for doing that mitigation. And so here, really, our end goal as an organization, our mission is methane mitigation. And so that's what's driven our focus in terms of what sources we look at. We have seen as well that, I'm presenting on the waste sector today, but we have other sector leads and other kind of in oil and gas. But for the waste sector specifically, we do see that these large point sources are contributing a large budget of the total emissions from the waste sector. So there actually is, really, really large potential to reduce emissions from this sector in particular through mitigation at landfills of these large point sources. But recognizing as well that, yeah, these other methane sources, including the natural sources, are very important. It's just not what our focus is as an organization.
Thanks, Michael. Thanks, Tia. We are over time now. Thank you all for attending. Thank you for all of your many questions. Apologies we couldn't get to all of them today, but we will follow up with some more resources from our website and materials, and also a webinar recording. So please stay tuned. And as Tia mentioned, a great way to just stay connected if we have more data on waste or information around waste that we put out. A lot of that is shared with our email subscribers. So please go ahead, head over to our website and subscribe to our newsletters and email communications. And yeah, excited to continue the conversation. Thank you.